Alright, so in the last video we looked at how we would graph the sine parent function. This video is going to deal with graphing the cosine parent function. So once again, we're going to use the unit circle. We'll be going around from 0 to positive 2 pi and then back down from 0 to negative 2 pi, graphing at each 90-degree interval. The cosine value is the x-coordinate on our unit circle. So that's what we'll be looking at as we fill in the t-table on this chart. Okay. So if we start at 0, we look at our coordinates on the unit circle. We see that cosine is 1 at 0. So it equals 1. If we move to 90 degrees or pi over 2, we see that cosine equals 0. If we move to pi or 180 degrees, we see that cosine equals negative 1. If we move to 3 pi over 2, 270 degrees, we'd see that cosine once again equals 0. And then as we move 360 degrees or 2 pi, we would once again see that cosine equals 1. All right, so from there we could start. So at 0, we're going to be at 1, and then move backwards to negative 2 pi. So at negative 90, which would be the same thing as positive 270, so negative pi over 2, we're going to be at 0. At negative pi, which would be the same thing as positive pi, we're going to be at negative 1. At negative 3 pi over 2, which would be the same thing as positive pi over 2, we're going to be at 0. And at negative 2 pi, which would be the same thing as 0 or positive 2 pi, we are again going to be at 1. So again, we can graph these points, put them on a standard xy coordinate plane, and find out what our cosine graph looks like, and then use it to solve for what cosine, where cosine would be at a specific range somewhere else along our x-axis. Okay, so let's plot these points on our graph down here. So at 0, I'll be at 1. At pi over 2, I'm going to be at 0. At pi, I'll be at negative 1. At 3 pi over 2, we'll be back at 0. And at 2 pi, we're going to be back at 1. If I start and I move backwards, at negative pi over 2, I'm at 0. At negative pi, I'm at negative 1. At negative 3 pi over 2, I'm at 0. And then at negative 2 pi, I am at 1. All right, so again, these are going to be some curved lines. We're not drawing straight points. So if I graph my cosine function from negative 2 pi to positive 2 pi, it's going to resemble a W. A lot of people find graphing the negative of this is much easier than the sine because this is more of a mirror image than the sine function, so it's kind of easier typically for students to grasp this. So again, we have a good bit of information here just looking at 2 periods. Much like the sine function, it has a period of 2 pi, so it's going to start over every 2 pi and repeat forever in either direction. So looking at from negative 2 pi to positive 2 pi, we can get a good bit of information to then graph between 3 pi over 2 and 7 pi over 2. All right, so let's go ahead and draw out our axis for this. Since we're not dealing with any negative numbers, I'm not going to worry about drawing a negative portion on my graph. I'm just going to keep my x-axis moving forward. Again, we'll draw a squiggly line signifying that we're going to have a little break. We're not actually starting at 0. My first line will be at 3 pi over 2. My last will be at 7 pi over 2. So I want to find a spot halfway between 3 and 7. So that would be 5 pi over 2. All right. Then I have these quarter marks here. All right. Normally I wouldn't even bother labeling the quarter marks, but in this case most students have difficulty telling where we are just by the fractions. These will be whole numbers, so this will probably help us out. So if I went from 3 pi to 5 pi, this is going to be 4 pi over 2, which would reduce down to 2 pi. And so that would make this 3 pi. All right, so we want to know where this graph is going to go from 3 pi over 2 to 5 pi over 2 to 7 pi over 2. So if I take a look at my parent function down here to that graph, I notice that unlike the sine, which was at the x-axis on all whole integers, my cosine function is at the x-axis in all of my fractions. So pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So at each one of these fractions here, this graph will be at the x-axis. So then for this graph, we just need to determine when it's going to be up and when it's going to be down. Well, in this case, it's kind of easy because this graph includes 2 pi, which is on our graph. So we would see that at even numbers, we are going to be at our maximum, and then at odd numbers like 1 or negative 1, we will be at our minimum. So if we graph this cosine function here, it's going to look like this. Sort of looks like a sine function because that's the snapshot that we are taking. We are taking a look at it in such a way that it makes it look like a sine function. However, we are graphing the cosine function just between a different interval. And much like the sine function, we can use this for a whole range of solving problems and different uses. Knowing the patterns and how this works and knowing how to draw these functions from memory will help you out immensely as you start messing with the amplitude and the period and shifting these functions by their phase or shifting them vertically. So really learning how to graph the sine and cosine parent functions comes in handy a lot in advanced math. So that's this problem. We are now going to look at a problem that deals with blood pressure that will be a sine or cosine graph. So I'll have that video up shortly. Thank you guys for watching. This is the Bearded Tangent. We'll catch you next time.